Hi everyone. I'll be explaining this problem called pushing balls. The problem actually said that you're going to be given an n by m grid, and um, in this n by m grid, you're gonna uh, take some numbers. The numbers can be either 0 or 1. What this grid would actually mean is a final state of something that you're going to do. Now, let's take one example. You would understand more. You see, this is one of the final state of the grid. I've drawn upon in here, um, here. This is the grid that you're going to input, and imagine this is the final step, or should I say, the final snapshot of a situation. But at the very beginning, it would look something like that. Okay, so you have to output whether it is possible to convert from this to this or not. So the answer is going to be either yes or no, whether you can get from this situation to this situation. You see, now uh, you can apply some number of you can perform operations here. Imagine this number one is actually a kind of a ball, or that you can actually drop inside this grid. Imagine this grid as a um, you know a basket or something. So you are going to input this value. You have the authority, or you have the power to put the value 1 inside this grid. But how does the format works or looks like? Well, for example, for each and every row, if we talk about, what you can do is you can put from the leftmost, you can actually insert a value. And when you do that, let's say you want to insert in this row, so you do the operation just like that. You throw the 1 like that, and the 1 then comes here. Okay, so let's erase it, and let's just draw 1. Okay, and then you want to put another 1, let's say, but directly in here. So as you know, another 1, if you want to put another 1, there's already a 1 here. What would happen is that that 1 will come here, and this one would move here. So in the next step, if you want to add another 1, what's going to happen is something like that. Okay, and let's say you want to add another 1. What would happen then? That 1 will come here, this one would come here, and the new one will come here. So as you know, what would the final output look like? 1, 1, 1. Similarly, like this fashion, you can do this for every row possible. Okay, for any row you can do this. You have the ability to do that. But you see, if any row covers with all the ones, then if you, after that, let's say, if I talk about the state here, let's say you have this. Now you want to add 1 again in this row. No changes is going to happen. Okay, no change. It's not possible. After you do this, it's not possible to add another 1 in, like that, because the spaces are actually covered. Now, in the same way, you could apply, as I've said, in the same way you could do that, apply that operation in here like that, and that, picking up ones for any of the rows. Similarly, you can also apply operations for each and every column. For example, okay, better be quick. Now, for example, you want to add, you can add values in a specific column, directing in a specific column like that. What would that look like? If you add 1 here, that 1 will come, and you would draw it here. Okay, now imagine you want to add another 1 here. What's going to happen? What's going to happen is simply this one will simply move here, and the new one will come here. So in the next step, it would look something like that, and so on and so forth. For any of the column, it's gonna work exactly like that. Now, that's the thing that you can actually do in order to you have the authority to do something like that in order to come to this. Now, the real question is how you're going to make sure that it is actually possible to come to this state from the initial center point, the initial the initial or the beginning version, which was like that. Now, how are you gonna make sure that it's a possibility? Now, what I tried to do is I said, okay, how do you think this example is actually possible? Well, I think I will add simply in the third row, I will add one, I will add two ones in the row 3, and I will add two ones in the column 3, and that's it. That's the answer. It might happen for some cases it's not the answer, but that's the main question. How do we figure out that I actually can reach this final state, and for some state I might not be able to reach it? Now, the solution that I had in mind was I said, okay, what is the operations, pattern? What is the pattern? What is the pattern? You see, for every row, I am always making sure the operations are happening in such a way that it's consecutive. For the row part, I would say it's left. From the left, you just check the prefixes, okay? And from the only the prefix consecutive ones. And from the similarly for the column, you just check each and every column's individual prefixes. What is the maximum number of ones are available in the particular subsequence? In the particular prefix. The maximum number, I mean, how far can you go by having ones, all the values are ones, meaning that prefix of ones. So that's going to make sure, and I will do that actually for each and every cell. I have to make sure I want to calculate. Okay, let's just start from the beginning. I want to calculate for each and every cell in the grid whether it is a successful position or not. If it's the value, if any value 1 is available in the final state, I'm trying to determine whether it is the successful position or not. Now, what do we mean by a successful position? What we mean by that, the one that comes here, I'm going to claim it is a successful position. Why? Because it is coming through an operation that is utilizing the manner, which is the prefix consecutive ones. Now you might say, okay, just give me an example of an unsuccessful position. I'll give you an example now. What it might look like. An unsuccessful position might look like something like that. Okay, let's say this, and 1 and 0. 0, 0, 0. Now you say, do you really think it's possible to achieve this state from all the values 0 initially, and you want to come up with this state following the operations that I talked about previously, where you add each and every row values in such a way that it deals the prefix part first and consecutively adds? Similarly goes for the column. There's no way you can add a 1 in here directly. If think about it, if you try from this row, what would happen? The 1 has to come here. If you want this 1 to come in the middle, you have to drag another 1 here. Otherwise, that ball or that value 1 is not going to come. So it is absolutely impossible. So this is my unsuccessful state. Now, that's exactly what my solution is. For each and every cell, I'm trying to compare, I'm trying to calculate whether it is a successful position or not. Now for this, how do I calculate this is a successful position or not? I will say, okay, Um, I know that it's an unsuccessful position. How do I calculate that? I would say, okay, let's for this cell, let's take the row. Okay, we have a 0 initially, but I don't want a 0. I want consecutive ones, you know? So from this end, I will say all the prefixes up here, they don't belong. You cannot apply operations like that in here. So I'm going to say that, okay, it's not possible. The value for this section, maybe a tracker that will say that, okay, this cell is not possible. Well, I will also check for this particular cell's column. It might happen that you might not be able to apply the operations on the row, but you can apply the operations from the column. What if the example was something like that? What if it was something like that? Then it might have been a possibility. Yes, now, if you see for this example now, it is possible, isn't it? You just apply from the column and it's possible. So for each and every cell, I have two possibilities to check. Whether it's possible from the left row, from its current row's left position, is this the consecutive one? If it's not, is it coming from the column? Can it be reproduced from the column? If it's not, then that cell is unsuccessful. So this is how I'm actually working. So if any of the rows or columns can contribute to that value 1, then I have the answer. Let's talk about this cell now. Why it's 1? Why it's yes? The reason it's yes is because for this cell, I know it's a consecutive from the row. I can say that it's a consecutive from the row. So for this two cells, it's 1. 1, yes, possible. For this column, I can also say, yes, I can do this from the column. So 1, and for this also 1. And for the rest of the cells, it's 0 because the value is not 1. So it's not a successful position. But when I track, when I come up with the answer, I will check whether a particular cell value is 1 or not. If it is 1, if it is 0, I don't care about it. If it's 1, I care about it, whether it's a successful one or an unsuccessful one. If it's an unsuccessful one, I completely break out of that loop, and I say the answer is no. If the value is 1 and it is a successful cell, I will check all the possible ones that are here inside this grid and check whether all of these ones are successful cell. If all of them are successful cell, then the answer is yes. To explain it a little bit more, I will go to the code section. You see this? That's the code. Now I'm trying to calculate the value here. First, I'm taking the input, and there you go. That's the part. This two parts are calculating. Now you see when I said that I will try to calculate whether a cell is successful or not. This possible 2D array named 2D array is going to keep track of that value, whether a cell is successful or not. Now this part is trying to deal with each and every row and trying to gather whether any of the values inside each and every row of the grid, if there's a possibility that this cell belongs to a consecutive one. If it does belong, then I will say that okay, it does have a possibility. Otherwise, it's not. So this part is all the successful ones I'm updating. This part is all the successful ones from the column perspective I'm updating. So this is it. That's how I'm actually doing the thing. And finally, I will check if any particular cell is 1 and the tracker of the possible, whether that cell, if it's an unsuccessful cell, then I'm completely going to break out. I'm going to say it's no. Otherwise, I will check for every possible cells, whether it's 1 and it's not, and it's absolutely successful. This indicating unsuccessful cell, and value is 1 and unsuccessful. No, I don't want that. That's not possible to come up with in this state. So I'm just literally breaking out from the loop and giving out the final answer as no. Otherwise, it's the yes. Now, one thing I also want to share with you is that what if the case looks something like that? I mean, let's take a look at it. What if the values are like that? Let's say 1 and then 0, 0, and then 1. What if values are something like that? You see, what do you think the successful cell and the unsuccessful cells are here from here? This, and this is successful. As I have encountered a 0, I don't care. This is the cell, okay? I'm comparing, okay, these are the consecutive ones, these are all successful. I've encountered a 0, I'm going to completely break out. I'm going to say all of them are unsuccessful in terms of applying from the row perspective. I'm just talking about the row perspective. And for the column perspective, I'm going to do the same thing and try to figure out that whether I have the answer or not. So I hope you understand. Whenever I encounter a 0, I know that after that 0, I don't care about the rest of the cells. They're unsuccessful with regards to the direction that I'm going. If I'm going in the row direction, it's not possible to make that cell after 0, any cell, successful in the perspective of row. Similar case goes for the column. So I hope I made you understand that. It was a great problem. I loved it. I hope you loved the solution too. So yeah, thank you very much. I really appreciate it. Thank you.